Greetings, Python enthusiasts. Today, we're delving into a powerful aspect of Python programming, generators. These versatile constructs provide a memory-efficient and elegant way to work with sequences of data. Join me as we explore the definition, characteristics, and typical use cases of generators in Python. Let's kick things off with a fundamental question: what is a generator? At its core, a generator is a special type of iterable in Python that allows you to iterate over a potentially large sequence of data without creating the entire sequence in memory. Generators are created using functions and the yield keyword. Now, let's delve into the characteristics that make generators unique. Number 1. Lazy evaluation. Generators follow a principle of lazy evaluation, meaning they generate values on demand, one at a time, rather than creating the entire sequence up front. This leads to significant memory savings. Number 2. Memory efficiency. Thanks to lazy evaluation, generators are memory efficient, making them ideal for working with large datasets or infinite sequences. Number 3. State preservation. Generators maintain their state between successive calls, allowing you to pick up where you left off in the iteration. To create a generator, you use a special kind of function called a generator function. Here's a glimpse of the syntax. The yield keyword is used to produce a value in the sequence. When the generator function is called, it returns a generator object that can be iterated over. Now that we understand the essence of generators, let's explore some typical use cases. Use case number 1, processing large datasets. Generators are excellent for processing large datasets where loading the entire dataset into memory is impractical. This generator function process_large_dataset uses with statement reading a file line by line, then adds line number for each line, yields a processed result for each line. This allows you to handle large files without the need to load the entire file into memory. The main function will invoke and iterate over the generator, print out each line as it becomes available after processing. We will run it with this large_data.txt file. But this file does not have large dataset, only has 3 lines of sentences, just for a demonstration purpose. Add breakpoint here and run it in debug mode. We can see how the generator yields the result to the main function. The run stops at breakpoint. Here, the result variable gets the first line of the file. And then we run the code step by step. Prints out the first line. Next step, the main function iterates to the next result. Because the data_processor is a generator function, it only yields one line at a time. It will need to go back to the generator function to read the second line of the file. See here, the processed_result variable has the line number 2 now. Then the main function prints out the second line. The same thing happens for the third line when continuing clicking on Step Into button. Let's look at use case number 2, infinite sequences. Generators are ideal for scenarios where you need to work with sequences of data that are conceptually infinite or are generated dynamically. This generator function infinite_sequence produces an infinite stream of numbers starting from a given value. The main function showcases how to use such a generator, printing the next 5 values from the infinite sequence. Please note, in line 10, using an underscore as a variable name for a parameter that will not be used within the for loop body, and in the line 11, using built-in function next for calling next sequence iterator. Let's run the code in terminal. The 10 to 14 of the 5 sequence numbers are printed. Use case number 3, efficient pipelines. Generators are integral to building efficient data processing pipelines, allowing you to transform data in a stream-like fashion. This pipeline generator function takes an input sequence of data and a variable number of transformation functions. It applies each transformation sequentially to each item in the data, yielding the transformed result. The asterisk in front of a parameter in a function definition is known as the splat operator, and it allows the function to accept any number of positional arguments. The main function demonstrates how to use the pipeline to square, and then +1 to each element in a list, showcasing the modular and composable nature of data processing pipelines. Run the code in the terminal. The results are printed after the data processed in the pipeline with square and then +1. And there you have it, a comprehensive introduction to generators in Python. These constructs offer a dynamic and memory-efficient approach to handling sequences of data. As you explore Python further, keep generators in mind for scenarios where lazy evaluation and memory efficiency are paramount. If you found this tutorial insightful, don't forget to like, share, and subscribe. Happy coding!